Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique right pentagonal prism having edge of the base 30 millimeter and axis height 65 millimeter. Now this pentagonal prism is resting on horizontal plane on one of its corners of the base and the axis is inclined at an angle of 60 degree with respect to the horizontal plane, whereas the side opposite to the corner on which it is resting onto the ground or onto the horizontal plane, this is inclined at an angle of 35 degree with respect to the vertical plane. So here we have got the pentagonal prism inclined with respect to horizontal plane as well as the vertical plane. So we are required to draw the orthographic projections of this oblique right pentagonal prism. Now let us first of all evaluate the orientation of this pentagonal prism onto the horizontal plane. So here, if we are going to locate the pentagonal prism into this orientation onto the horizontal plane, now you see what's going to happen. If we are going to tilt this prism with respect to the horizontal plane, so it will be resting on one of its corners of its base onto the horizontal plane. Either we tilt it this way or we tilt it this way. So it will be resting on one of the corners of its base over there onto the horizontal plane. But in the second instance, we have been provided with the information that the side which is opposite to the corner onto which it is resting on the horizontal plane, so this side is further inclined with respect to vertical plane at an angle of 30 degree. So now whenever the prism will be resting either on this corner or on this corner, so when we incline this prism, we will find that either this side or this side. So these sides will be becoming apparent lengths in the top view projections over there. So we are not going to get the true length of the base edge opposite to the corner onto which it is resting to be true length in the top view. So this way, this orientation of the pentagonal prism with respect to horizontal plane, it seems to be incorrect. Whereas into this situation, if we are going to assume that if we locate the pentagonal prism onto the horizontal plane into this orientation, then we are going to tilt this particular pentagonal prism with respect to horizontal plane in this orientation. That is, whenever we incline the pentagonal prism with respect to the horizontal plane such that the axis is inclined at an angle of 60 degree with respect to HP, so the pentagonal prism will be resting on this corner of its base onto the horizontal plane. It will be this corner. So once we tilt it this way, it will be resting on the horizontal plane on this corner. And another thing we are going to observe, that this is the base edge or the side opposite to the corner onto which it is resting. It is this particular side. So this side, it will still be parallel to the horizontal plane. And since this side will be parallel to the horizontal plane, so we are going to obtain the true length projections of this side opposite to the corner onto which it is resting onto the horizontal plane. So this side will be still true length in the top view projection. So in the second instance, this side which is opposite to the corner onto which it is resting, it is further inclined at an angle of 35 degree to the vertical plane. So in the second iteration, we are going to incline this side or this side at an angle of 35 degree with respect to the vertical plane. So this is the correct orientation of the pentagonal prism onto the horizontal plane. So now let us begin with the construction of the orthographic projections of a right pentagonal prism when the pentagonal prism is resting onto the ground on its base over there. So we know that the edge of the prism happens to be 30 millimeter. So now we are going to draw the top view projections of this particular prism onto the horizontal plane. So these top view projections will be drawn below the XY reference line. So once we draw the top view projections onto the horizontal plane, we are going to observe that one of the edge of this pentagonal prism base will be perpendicular to the vertical plane. So once we draw the edge length is equal to 30 millimeter, now we will have the pentagonal projection of this pentagonal prism onto the horizontal plane. Now let us label the different points of this pentagonal prism. So here we can see A, B, C, D and E. So these are 5 points of the base of the pentagonal prism, whereas 1, 2, 3, 4 and 5. So these are the 5 points corresponding to the top face of the pentagonal prism. So the base points and the top face points, they have been marked onto the top view projections. Now we need to work out the access points of this particular pentagonal prism. So the access point, there will be 2 access points, one access point corresponding to the top face and another access point corresponding to the base of this pentagonal prism. So in order to evaluate the access point for this pentagonal prism, now we need to draw at least 3 perpendicular bisectors from 3 of the corners of this pentagonal prism onto the opposite edges over there. So from point D, we have drawn a perpendicular bisector of AB. From point B, we have drawn a perpendicular bisector of the edge DE over here. Similarly, so also we have drawn from the point C perpendicular bisector of the edge AE. So wherever these 3 projectors, they are going to join, so here we are going to obtain the access points O and O1 over here. So O point will be lying at the top face and O1 point will be lying at the base of this particular pentagonal prism. Now having obtained the top view projections of this right pentagonal prism which is resting onto the base on the horizontal plane, now let us evaluate the front view projections of this pentagonal prism. Now we can see corresponding to the base, B dash and A dash points will be located onto the XY reference line. Similarly, corresponding to the base points C and D, so we are going to obtain C dash and E dash points onto the XY reference line. And finally, corresponding to the base point D, we are going to obtain point D dash onto the XY reference line, because the pentagonal prism is resting on its base onto the horizontal plane. Now we know that the axis height of this pentagonal prism happens to be 65 millimeter. So once we know this axis height, now we can construct the front view projections of this particular pentagonal prism over here. So this height of the axis or height of the pentagonal prism will be equal to 65 millimeter. So here we can see corresponding to the top face points, we can check 2 and 1. So they will be projected as 2 dash and 1 dash over here. Points 3 and 5, they will also be overlapping. So we are going to obtain 3 dash and 5 dash at the top face. And finally, corresponding to this point 4, we are going to obtain point 4 dash at the top face of this pentagonal prism. So one thing we must remember, that this vertical edge 1A, it is lying at the back. So it should have appeared as a dotted line in the front view projection. That is 1 dash, A dash should have been drawn as a dotted line, because this vertical edge, it is lying on the rear side of the solid. But this vertical edge is being superimposed by, it is being overshadowed by the front face vertical edge, that is 2B. So this vertical edge 2B, it is to be drawn with the help of an object line. This vertical edge 1A, it should be drawn with the help of a dotted line. But this dotted line corresponding to 1 dash A dash will be superseded by the object line corresponding to the edge 2 dash B dash over here. Similarly, the edge, we can check over here phi e. So this is the edge 5e over here, vertical edge. So this vertical edge 5e, again it is lying on the rear side of the observer over here. So this phi dash and e dash, it should have been drawn as a dotted line or a hidden line over here. But since phi dash, e dash edge, it is being superseded by, it is being superimposed by the vertical edge 3c over here. So that is why we are going to get the object line projections corresponding to the edge 3 dash c dash over here, superimposing the hidden line projections corresponding to the edge phi dash e dash over here. So these are the front view projections of the pentagonal prism. So here we have got O dash axis point on the top face, O1 dash axis point is lying at the base of this particular pentagonal prism. Now, having obtained the front view projections as well as the top view projections of this right pentagonal prism resting on the horizontal plane onto its base, now we are provided with the information that this pentagonal prism is resting on one of its corners of its base on the horizontal plane, while the axis of this pentagonal prism is inclined at an angle of 60 degree with respect to the horizontal plane. So as we tilt, please see, as we rotate or as we tilt this pentagonal prism with respect to horizontal plane in such a way that the axis will be inclined at an angle of 60 degree with respect to horizontal plane, or the base of this prism will be inclined at an angle of 30 degree with respect to the horizontal plane. So then this prism will be resting on one of its corners. So this will be the corner D dash over here. So onto the corner D dash, we have to reorient or redraw or rotate this particular front view elevation projections in such a way that the base of this pentagonal prism will be inclined at an angle of 30 degree, or the axis of this prism will be inclined at an angle of 60 degree with respect to the horizontal plane. So let us proceed with the transformation or rotation of the front view projections of this pentagonal prism. So to begin with, we have to draw a projection line corresponding to the base of this prism at an angle of 30 degree. So please check, we are not going to mark this angle of 30 degree. Why? Because we have been provided that the angle of inclination of the axis is 60 degree. But in order to facilitate the construction, we have to ensure that this point D dash should be lying over here. So that is why we are going to draw the angle of inclination of the base is equal to 30 degree, and thereafter we are going to mark the angle of inclination of the axis as 60 degree over here. So once we draw the angle of inclination of the base as 30 degree, now point D dash will be shifted over here as point D1 dash. Now this is our point D1 dash. The moment we obtain point D1 dash, now you see, using rectilinear distances principle, we are going to transfer these front view elevation projections into the new inclined orientation over here. So how we have transferred this view over here? So please check, this is our point D1 dash. So we know the distance between D1 dash and C1 dash and E1 dash over here. So this distance will be equal to D dash, C dash, E dash distance. So we are going to mark this distance. So the moment we mark this distance, point number 1 will be marked over here. We also know the distance between D dash and B dash, A dash over here. So once we mark this distance, so I can mark this distance is equal to D1 dash, B1 dash and A1 dash distance over here. So this distance we have marked equal to this distance over here. And also we know that the height of this pentagonal prism, it happens to be 65 millimeter. So from point 1, point 2 and point 3. So perpendicular projection equal to 65 millimeter we have marked. So we have been able to transfer or rotate the front view elevation projections over here. Now we know that axis is lying over here. So we can measure the distance between D dash and O1 dash over here. So once we measure the distance between D dash and O1 dash, so this point corresponding to the axis will also be located. And once again I draw 65 millimeter perpendicular projection, so I will be able to obtain this point as O1. This point will be O11, and this angle of inclination of the axis will automatically be equal to 60 degree. Now once I am able to incline this pentagonal pyramid in such a way that it is resting on one of its corners of its base, that is D1 dash, onto the horizontal plane, and the axis of this particular pentagonal prism happens to be inclined with respect to the horizontal plane at an angle of 60 degree. So I am able to obtain the front view projections of this right pentagonal prism having axis inclined at 60 degree to the horizontal plane. So now, having obtained the front view projections, now as the observer is going to look at this pentagonal prism from the top, I have to obtain the corresponding top view projections of this particular pentagonal prism. Now let me check how many points I do have in the front view projection. 5 points corresponding to the base, 5 points corresponding to the top, and then 2 points corresponding to the axis. O1 dash will be lying at the top face and O11 dash will be lying at the bottom face. So I am going to get 6 points corresponding to the base, 6 points corresponding to the top face of this pentagonal prism. So I have got 12 points in all. So from these 12 points of the front view elevation projection corresponding to this inclined pentagonal prism, I am going to draw the vertical projector lines extending into the plan projection view. Now, having drawn the perpendicular projectors from the 12 points of the elevation projection view, now one by one we will be drawing horizontal projector lines from these 12 points which are available with us in the previous plan projection view. And now wherever the horizontal projector lines drawn through these 12 points, they will be intersecting with the corresponding vertical projector lines drawn through the same points. So the points of intersection of the horizontal projector lines and the corresponding vertical projector lines will be providing us with the corresponding points of the plan projection for the inclined pentagonal prism over here. So let us proceed now. So first of all, we are having the points E and phi. So the first point which is encountered is E phi. Now from E and phi, we have drawn a horizontal projector line. Wherever this horizontal projector line will be intersected by vertical projector lines drawn from E1 dash and phi 1 dash. That is, this is the vertical projector from E1 dash. So this point of intersection will be providing us with the location of E1. Similarly, this point is phi 1 dash. So from phi 1 dash, once we draw a vertical projector line, so wherever it intersects with this horizontal projector line drawn through the point 5, we obtain the point phi 1 over here. Now the next point which is available with us, it is 1A. So from 1A, again we have drawn a horizontal projector line. Now we are going to extend this horizontal projector line till it is intersected by vertical projector lines drawn from 1-1 dash and A1 dash. So here we can see this point is A1 dash in the front view elevation. So once I draw a vertical projector line, it intersects with this horizontal line. So this intersection provides us with the location of the point A1 over here. Similarly, here we have the point 1-1 dash. From 1-1 dash, we have the vertical projector line. Wherever it intersects with this horizontal line drawn through the point 1, we have obtained the point 1-1 in the top view projections over here. Now the next point which we are going to discuss is 2 and B over here. This point is 2 and B. So from 2 and B, again we have drawn a horizontal projector line. Once we draw a horizontal projector line through 2 and B, now wherever this horizontal line will be intersected by the vertical projector lines emerging from B1 dash and 2-1 dash, we will be obtaining the points B1 and 2, 1. So please check, this is B1 dash. From B1 dash, we have drawn a vertical projector line. So this vertical projector line intersects with this horizontal projector line drawn through the point B. So this intersection point provides us with the location of the point B1 over here. Similarly, this point is 2, 1 dash. So from 2, 1 dash, once again, we have drawn a vertical projector line, and wherever this vertical projector line intersects with the horizontal projector line drawn through the point 2, we have obtained the point 2, 1 over here. And next we have got the point 3 and C over here. This is C and 3. Now onto this horizontal projector line, we need to evaluate the points of intersections corresponding to the points C1 dash and 3, 1 dash. So please check, this point is C1 dash, this point. So from C1 dash, we have drawn a vertical projector line. Wherever this vertical projector line intersects with this horizontal projector line drawn through the point C, we have obtained C1. Similarly, this is the point 3, 1 dash. So from 3, 1 dash, we have drawn a vertical projector line and extended it up to the point where it is going to intersect with the horizontal projector line drawn through the point 3. So point 3, 1 is also obtained. And finally, we have got these 4 points, O, O1 and D4 over here. So once we draw a horizontal projector line through these 4 points, now onto this horizontal projector line, 4 points we are going to obtain. Which one will be these points? D, 4, O and O1. Now please check, onto this horizontal projector line through D and 4, I have evaluated the perpendicular projectors from 4, 1 dash. So please check, the 4, 1 dash vertical projector is going to intersect with this horizontal projector at this point, yielding us with the point 4, 1 over here. Similarly, this is our point D1 dash corresponding to the base point. So from D1 dash, if we draw a vertical projector line, wherever it intersects with this horizontal line drawn through the point D, we have obtained the point D1 over here. Now finally, let us evaluate axis point. So we have drawn this projector line, that is horizontal projector line through O and O1. Now let us evaluate. This is the point O1, 1 dash. If I draw a vertical projector line through this point will be O1, 1, the intersection point. Similarly, this is the axis point of the top face. If I draw a vertical projector line through O1 dash, and wherever it is going to intersect with this horizontal line drawn through the point O, so we will be obtaining point O1 over here. So now all the 12 points of the top view projection corresponding to this inclined pentagonal pyramid have been obtained. Now which are the edges which we want to join? A1 B1, B1 C1, C1 D1, D1 E1 and E1 A1. That is all the edges of the base we need to join. Then we also need to join 1, 1, 2, 1, 2, 1, 3, 1, 3, 1, 4, 1, 4, 1, 5, 1, 5, 1, 1, 1 and 1, 1, 2, 1 over here. Again, all the edges of the top face. Also we need to join 1, 1 A1, 2, 1 B1, 3, 1 C1, 4, 1 D1, 5, 1 and D1 over here. So this way we have to join all the vertical edges over here. But which one of these edges they have to be joined dark or using the object line? Which one of these edges they have to be joined using the hidden line over there or the dotted line projections over here? So now since the observer is going to look at this object from the top, so now the farthest point away from the observer happens to be D1 dash. So anything joining D1 in the top view projection has to be joined as dotted line or a hidden line, unless those edges they are constituting the boundary of the solid. So let us join the top face edges. So they will be joined using object line because they are visible to the observer, because the observer is going to look at the solid from the top. So 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, they have been all joined using dark line. And anything joining D1, because these three edges, they are joining D1 and they are not falling in the boundary of the solid. So they have been drawn as hidden lines or the dotted line. So D1, E1, C1, D1 and D1, 4, 1. So these three edges, they have been joined as dotted one. And now rest everything will be joined as object line or a dark line over here. So now we have been able to obtain the front view projections as well as the top view projections of this inclined pentagonal pyramid when the axis of this pyramid is inclined at an angle of 60 degree and the prism is resting on one of its corners onto the horizontal plane. Now one thing we have observed over here, in the second iteration we have been provided with the information that the side which is opposite to the corner onto which it is resting on the horizontal plane, it is further inclined at an angle of 35 degree with respect to the vertical plane. So which is this side? It is this corner D. Please check, it is this corner D over here. So opposite edge is this one. So this edge happens to be A1, B1. Now as we have tilted this prism, still this edge A1, B1 happens to be parallel to the horizontal plane. So onto the horizontal plane into the top view projections, we have been able to obtain the true length of this edge which is opposite to this corner D1 over here. So please check, this is the corner D1 onto which it is resting onto the ground or onto the horizontal plane. So the opposite edge is A1, B1. That is A1 dash, B1 dash in the front view or A1, B1 in the top view. Now we have been provided with the information that this edge A1, B1 is further inclined with respect to the vertical plane at an angle of 35 degree. So this angle of inclination we have marked as phi. Phi is the angle of inclination of the true length, and we have got true length available with us because A1, B1, it is a true length which is an edge opposite to the corner onto which the pentagonal prism happens to be resting onto the ground. So onto this orientation line which is drawn at an angle of phi is equal to 35 degree, our edge A1, B1 will be lying over here. So now what we are required to do, we have to rotate or transfer this top view projection from the present orientation into a new orientation over here in which A1, B1 will be lying alongside this orientation line which is marked at an angle of 35 degree with respect to the vertical plane. So how we can transfer this figure over here? We can transfer the top view orthographic projections of this inclined pentagonal prism by using the principle of rectilinear distances. So we can see that these entire projections of the inclined pentagonal pyramid, they have been inscribed into the rectangular shape construction which is inscribing this total projection, that is the top view projection over here. So now this is the shorter side. So what I can do, please you can see this is the shorter side which I have drawn over here and this is the longer side over here. So once I draw this shorter side, I know that how many points are there. Point number 1, this is point number 1. This is point number 2. This is point number 2. This is point number 3. This is point number 3. This is point number 4. This is point number 4. This is point number 5. This is point number 5. So onto the shorter side, you can see 5 points I have marked. So I can work out the distances between these 5 points. Point 1 and 2, 2 and 3, 3 and 4, and 4 and 5. So all these distances, they have been marked over here. Now using rectilinear distances, I can mark these distances. Distance 1 vertical, distance 2 vertical, then I have got distance 3 vertical, distance 4 vertical, distance 5 vertical, distance 6 and distance 7 over here. So please check point 1, 2, 3, 4, 5, 6 and 7. So these you can see vertical distances also I have marked over here. This is 6 and this is 7. So up to 6 I have marked total and 1 point I have marked over here, that is distance number 7. So now corresponding to these points, you see there are 12 dots which I have shown corresponding to the 12 points of the plan projection view. 12 dots or 12 points, they have been marked over here. So now these 12 points I am going to mark it over here. Please check. A1, B1. So this point will be A2, B2. This point is O11. This point will be O21. This point is E1 and C1. This point will be E2 and C2. This point is, you can check, 1, 1 and 2, 1. So this point will be 1, 2 and 2, 2. This point is D1. This point is D2 over here. This point is O1. This point will be O2 over here. This point is 5, 1, 3, 1. Here you have points 5, 2 and 3, 2. And finally here you have the point 4, 1. This point will be 4, 2. So once we have marked all these points, so in the same way, whichever way these edges they were joined in the plan projection view, so same way this plan projection view has been transferred into the new orientation at an angle of 35 degree with respect to the vertical plane. So this way we have been able to obtain the top view projections of an oblique pentagonal pyramid in which axis is inclined at an angle of 60 degree and the base opposite to the corner onto which the prism is resting onto the ground, it is inclined at an angle of 35 degree to the vertical plane. Now having obtained the top view projections of this pentagonal pyramid which is inclined to HP and VP both, now we are required to evaluate the front view projections corresponding to this oblique prism over here. So how these projections will be evaluated? Now please check, as the observer is going to look at this prism from this side. So now there are 12 points available over here in the plan projection view. Now from all these 12 points, we are going to draw the vertical projector lines, extending them up to the elevation projection view. And then from the elevation projection view of the previous construction, now we are going to draw the horizontal projector lines. Wherever these horizontal projector lines, they will be intersecting with the corresponding vertical projector lines emerging from the same points. So we will be obtaining the corresponding points of the elevation projection view of the oblique solid. So let us start with this. So here first of all we have got the point D1 dash available with us. So the first point available with us is D1 dash. So from D1 dash, please check, we have drawn a horizontal projector line, right? So wherever this horizontal projector line which is coinciding with the XY reference line, it will be intersecting with the vertical projector line. Please check, vertical projector line emerging from the point D2. This is our point D2 from the plan projection view. So if we draw a vertical projector line through D2, wherever it will intersect with the XY reference line or the horizontal locus line or the projection line emerging from D1 dash, we have obtained the point D2 dash over here. Now the next points which are encountered, they are C1 dash and E1 dash. Now from C1 dash, E1 dash, again we have drawn a horizontal projector line. So wherever this horizontal line will be intersected by vertical projector lines which are emerging from C2 and E2. So the 2 points we are going to obtain over here. So please check, this is point C2, this is point T2 over here. So from C2, this vertical projector line we have drawn, so it intersects with this horizontal line over here, providing us with the location of the point C2 dash. Similarly, this is the point E2. So from E2 we have drawn one vertical projector line, it intersects with this horizontal line emerging from E1 dash. So this intersection of these two lines, it provides us with the location of the point E2 dash over here. Now the next point is B1 dash and A1 dash. So from B1 dash, A1 dash, again we have drawn a horizontal projector line. Now wherever this horizontal projector line will be intersected by vertical projector lines emerging from B2 and A2. So 2 points B2 dash and A2 dash will be obtained over here onto this horizontal line. So please check, this is point B2. We have drawn a vertical projector line through B2. So intersection with this horizontal line emerging from B1 dash will provide us B2 dash. Similarly, this point is A2. From A2 we have drawn a vertical projector line. Wherever this vertical projector line drawn through A2 intersects with horizontal projector line drawn through A1 dash. So this point of intersection provides us with the location of the point A2 dash. So all the 5 points of the base, they have been located in the elevation. Next, let us evaluate 5 points of the top face. So this is point 41 dash. From 41 dash, we have drawn a horizontal projector. From the point 42, this is point 42. We have drawn a vertical projector over here. So wherever these two projector lines they intersect, we have obtained the point 42 dash over here. So the next we have got points 31 dash and 51 dash. So from 31 dash, 51 dash, again we have got a horizontal projector line. So wherever this horizontal projector line, it will be intersected by the vertical projector lines drawn through the points 3, 2 and 5, 2. So where is 3, 2? 3, 2 lies here. So from 3, 2, please check. If we draw a vertical projector line, wherever it intersects with this horizontal line, we have obtained the point 3, 2 dash. Where is 5, 2? 5, 2 lies here. From 5, 2, if we draw a vertical projector line, wherever it intersects with this horizontal line drawn through 5, 1 dash, intersection of these two projector lines have provided us with the point 5, 2 dash in the front view projection. And finally, we have the points 1, 1 dash and 2, 1 dash. So onto this horizontal projector line, wherever the vertical projectors from 1, 2 and 2, 2 will be intersecting. So the 2 points 1, 2 dash and 2, 2 dash, they have been obtained. So please check. This is 1, 2. From 1, 2, we have drawn a vertical projector line. Wherever it intersects with this horizontal projector line drawn through 1, 1 dash. So this intersection has provided us with 1, 2 dash. Similarly, where is 2, 2? 2, 2 is available over here. Please check this point. So once we draw a vertical projector through 2, 2. So this intersection of the vertical projector with this horizontal projector drawn through 2, 1 dash. So this has provided us with the location of 2, 2 dash. Now all the 10 points corresponding to the top face and the bottom face, they have been evaluated. Let us now evaluate the axis point. Now here you can see axis point is O1 dash corresponding to the top face. So we draw a horizontal projector through O1 dash. Now where is O2 lying? O2 is lying over here. This is O2 point, this point. So from O2, if we draw a vertical projector, it will intersect with this horizontal projector drawn through O1 dash over here. So this provides us with the location of O2 dash. And finally O11 dash is lying over here, this point. So from O11 dash, we have drawn a horizontal projector. From O21, you can check, this is the vertical projector. So this intersection has provided us with the location of the point O21 dash. So all the 12 points, they have been located. Now, which of the edges they will be joined dark? Which one of the edges will be joined using hidden line? That we have to evaluate. Now please check. Once the observer is going to look at this prism from this side, so the farthest point from the observer is A2. So anything joining A2 dash in the front view should be drawn as dotted or the hidden line unless it is falling into the boundary. So let us join top face edges 1, 2 dash, 2, 2 dash, 3, 2 dash, 4, 2 dash, 5, 2 dash and 1, 2 dash. Let's join the base edges. So now these edges A2 dash, B2 dash and A2 dash, E2 dash, they are not falling in the boundary. So they have been drawn as dotted or the hidden lines over there. Similarly, 1, 2 dash and A2 dash is also not falling in the boundary. So this will also be joined by using a dotted line or a hidden line. Rest everything will be joined using dark line. So we have also joined 2, 2 dash, B2 dash, 3, 2 dash, C2 dash, 4, 2 dash, D2 dash and 5, 2 dash, E2 dash at dark edges over here. And finally, we need to join axis also. So axis top point is O2 dash. Axis base point is O21 dash. So now this is the axis which we have joined over here using axis notation. Now once we have been able to obtain the front view elevation over here, so we have obtained the front view projections as well as the top view projections of an oblique pentagonal prism which is inclined with respect to the horizontal plane and which is inclined with respect to the vertical plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we evaluate orthographic front view and top view projections of right pentagonal prism, in which the axis is inclined at an angle of 60 degree with respect to the horizontal plane, while the prism is resting on one of its corners onto the horizontal plane, and the edge opposite to this corner onto which it is resting onto the horizontal plane, this is inclined with respect to vertical plane at an angle of 35 degree. So we will be continuing with further discussion regarding few more illustrative cases of projections of oblique solids in the coming lectures. So thank you very much. Thanks a lot.